Okay. Now, if I'm not wrong, you actually stop at question 11, meaning question 12 onwards, you didn't get a chance to go through the questions and the answers. Am I right?
Not
Do you still
really.
remember? The rest of you? Joshua, you remember this?
I
No,
don't think
because
so.
I just
I don't
joined.
think so. I
This
don't
is
think
my
so. I remember this.
Oh,
this is
Joshua,
my
you
first
only
lesson.
I see. Okay.
Yes, I
So
cancelled my subscription.
you cancel your subscription to what?
I cancelled my P6 renewal because busy year.
Okay. Subscription to what?
ADA tuition 4 subjects.
You cancel it, ah?
Yeah. I'm gonna
Okay.
just wait for the valid date to expire.
Oh, you're just waiting for the whole thing to expire.
Yes, it's valid
And
until
they ask
24
you,
February.
so they asked you to attend this lesson today.
My father just enrolled me in and see if it's good, and then if it's good, I will maybe enroll back in.
Okay, so you have to consider, right? Now, who is the person whose name is
Yes.
not here? Who is the person whose name is not here? Nabil? Okay, Nabil, don't play a fool like this, okay? Nabil, turn on the camera now.
My camera's having some trouble.
Okay, Ange and Nabil, I'm waiting for you to turn on the camera.
Can you see me? Because I see myself sideways and I can't adjust it by any way.
Joshua, I need you to do me a favor. I need your cooperation here. Okay. If you are going to communicate with me throughout the lesson, I think it will not be possible for me to go through all the questions that I need to go through. All right. So you're not going to unmute yourself until I tell you to do so. Is that all right? Okay. Thank you. Ange, I want you to turn on the camera. I think we have this agreement together with your dad. Good. Stay this way. Nabil? Okay. Thank you. Right, so let's look at this question. Now, all of you, can you turn to your worksheet number 6, and let's look at question 12. All right, those of you without this worksheet is okay. Just look at the questions. All right, these are the questions that you need to actually go through because you have been given this piece of work 2 weeks ago. So last week, you only managed to cover up to question 11. That means question 12 up to question 17, right? Still need to go through today. And then we have one more worksheet 7, okay, where we have to go through 18 MCQ. Good thing that is MCQ. Okay, that topic is actually photosynthesis. How many of you have these 2 worksheet review and you have completed all the questions? Hands up. The rest didn't. Okay, Julian did. Ian, did you do? Getso did. All right. Okay, Joshua. Okay, Shamu also. Okay. Ange, do you do this? Nabil? Keith? Have you done this? Not yet, huh? Okay. Okay. Good. Pranati also did it. Good. Right. So let's look at this particular question. Some processes involving energy changes are listed below. Okay, so you have burning of natural gas. You also have coconut dropping from a tree, right? Polishing a piece of wood with sandpaper, running water, spinning a turbine connected to a generator. Which one of the following diagrams correctly shows the energy changes in the processes above? Joshua, you want to answer this, is it? Okay, what's your answer for this?
Can I annotate it?
Okay, for this question, yes. You want to annotate that?
Yes.
Do you know how to annotate on this?
I may have some trouble because I'm using a mouse.
Okay, then maybe you don't do it, all right? Because today we are short of time. We have 2 worksheets to go through. Can you just tell me your answer for now?
Okay, I think I may have gotten too puzzled with this.
Someone else answer the question. Pranati, do you know the answer to this question? You don't know. Okay, so what is the burning of natural gas? Natural gas is actually a form of fuel. So when you burn fuel, what do you get?
Heat.
Okay, good. Shamu, you answer that, is it?
Yeah.
Good. So when you have fuel, you burn it, you get heat. So what does fuel contain?
Chemical potential energy.
Okay, very good. Chemical potential energy. All right. So potential energy is like stored energy, is stored inside. So when you start burning it, it just continues burning. Yeah, and it gives out a lot of heat energy. So already, if you are going to look, since this is letter A, look at all the processes. Which one tells you potential energy to heat energy? Okay, Shamu, I think you have the answer already, right, Shamu? Okay. So you go from potential energy, all right, potential energy to give you heat energy. Shamu, do you have the answer now? So that means you look at, let's say, option A. You look for
Is it
potential
C?
energy. C. Okay. Here, chemical potential energy to heat energy. And A is over here, right? Sorry, 1 minute. See, can you see the A? Same thing, right? So burning of the natural gas. Burning of the natural gas. So your chemical potential energy, all right, which is the natural gas. Upon burning, it gives out heat energy. So far, okay? Yes, Joshua.
Okay, I may have to stop my video because I just checked my task manager and my CPU is running hot at 60 degrees.
Okay. All right. You have to mute yourself, huh? Okay, so you check whether the rest are correct. That means you have to check for B, C, and D. Okay? So let's say I look at B, right? B tells me coconut dropping from a tree. Coconut is actually on top of the tree, right? It dropped. So when it is on the tree, it is at a certain height. Okay, so when it's at a certain height, what kind of energy does it possess?
Gravitational potential energy.
That's right. Okay, when you're talking about something at a certain height, it has got some kind of stored energy, right? The potential energy. Okay, whenever you mention height, it will have to be gravitational potential energy. So in this case, now you understand why they don't want to list whether it's chemical or gravitational. They just put the whole thing as potential energy. So when you are looking at B, that potential energy we're talking about is gravitational, right? When it drops from the tree, it's moving. Movement is referred to as kinetic energy, right? The body possesses kinetic energy, that's why it's moving. Or you can say because it's moving, that's why it possesses kinetic energy. Clear about this, Julian? Okay, no? Julian, make sure you're okay. This kind of energy changes is often tested in exams. So all of you need to be very, very clear of this. Okay, then next, if you look at C, polishing a piece of wood with sandpaper. Have you all tried using sandpaper before? Good. So if you have tried that, if you have not, okay, then you will have to probably ask for your father's or mother's permission. Okay, if let's say there is sandpaper at home, right? You try to do this yourself. Okay, when you are polishing a piece of wood, make sure it's a piece of wood that you don't want already. You polish it. You will know what I mean. The act of polishing. So let's say I'm holding on to a piece of the sandpaper and I'm polishing. Do you see my hand moving? Hand moving, what kind of energy is there? Whenever it's movement, it has to be kinetic energy, right? So kinetic energy, after you sand the piece of wood for some time, you touch the sandpaper or the piece of wood, it will feel warm because there's a lot of friction. Friction is very, very, the friction there is very, very great. Okay, so the frictional force is great, and then a lot of heat is generated. So C is correct also. Can you see? Kinetic energy to heat energy. Then what's next? We have to look at D, right? Running water. The moment you see running water, this is movement again, so kinetic energy. Okay, it's used to spin a turbine connected to a generator. Generator always related to electricity. Generator always is related to electricity. All right, so the running water means there is a lot of kinetic energy. Okay, and then the turbine spins, then the generator can produce this electricity. So electrical energy. So C is correct. Thank you, Shamu. Question here? Next. Now the diagram below shows a child sliding down a slide. The graph next to the diagram shows the amount of different types of energy at point A. This is point A. Okay, they even put a line here, right? So at point A, okay, when the child slides down, okay, at this particular point, the amount of energy for kinetic is this amount. Okay, potential energy is here. Heat energy is at this level. All right. So after a sudden downpour means a lot of rain. The slide was wet. Okay, but the child still continued to play. After raining, like he didn't play in the rain. He played after the rain. The slide was wet, but he doesn't mind. He just wants to play. So which graph will then show, okay, the amount of different energy at A when the child slid down the wet slide? Yes, Joshua?
Okay, I think I learned how to annotate.
Your answer is B. Okay. Now, Joshua, I want you to explain to me why is your answer B?
Because sorry, once again. Because the slide is wet, there is less frictions, so there's more so there's more kinetic energy and less heat energy generated by the friction.
Okay, good. Potential energy?
Potential energy stay actually stays the same because